By scrutinizing images from the Hubble ultra-deep field, the deepest images of the sky ever made, researchers have gained fascinating new insights into the distant universe. Knowledge about our cosmic roots. One of the most fundamental questions we all ask ourselves is, where do we come from? The Earth, the Sun, and our entire solar system is part of the Milky Way galaxy. So the question of our origin is closely linked to the birth and evolution of the galaxies. By joining forces, the European ESA Hubble Space Telescope and the American NASA Spitzer Space Telescope have discovered some of the smallest, faintest, and most compact galaxies ever observed in the distant universe.
What we see is the past directly, and this is because light has a finite speed of about 300,000 kilometers per second. So we always see emitting things as they looked when light was emitted. So for the Moon, this means that we see 1 second back in time. Right? And for the Sun, it's about 8 minutes, and for Pluto, maybe 6-7 hours. And then for the galaxies, it's much further back in time because they're so far away. So for instance, for the Andromeda galaxy, we see about 2 million years back in time. And in these cases, in the Hubble ultra-deep field, we see much further back in time because these galaxies are so far away. So we see back to maybe 10-11 billion years back in time.
According to conventional theories, the massive galaxies known today have developed by merging of smaller galaxies in the early universe. But does theory coincide with reality? The answer may well lie in the observations of young galaxies. We might even call them baby galaxies from the early universe. Recent observations of young galaxies give entirely new insight into the period when galaxies in the universe were first formed, less than 1 billion years after the Big Bang. In the 9 pristine galaxies, the Hubble telescope has detected very blue stars.
Blue star is a hot star, so it simply means it has a very high temperature at the surface. And this we know when we heat up iron, for instance, it starts being red and then it becomes white blue when it gets very hot. So blue stars are very hot stars, and the hot stars are the most massive stars. They simply have a higher temperature on the surface. And these stars only live for a few million years. I mean, it's a long time for us, but for stars it's a very short time. The Sun lives for 10 billion years, so it's a factor of 1,000 longer. And these massive blue stars, we only see them in galaxies that are just forming new stars. And we know blue stars, or massive stars, from our own galaxy in the Orion, for instance. We see these in the belt of Orion. There are 3 stars, and 2 of these are very massive blue stars with a mass of more than 20 times that of our Sun.
The galaxies were observed in the Hubble ultra-deep field with Hubble's advanced camera for surveys and the near-infrared camera and spectrometer. Spitzer's infrared camera was also used, as well as the European VLT Observatory's near-infrared camera and spectrometer. The galaxies are baby galaxies, hardly formed, at a very early stage of development. The images here show computer simulations of glowing clouds of gas in a newly formed galaxy.
What we see here is the gas in a young galaxy. So it's in a young galaxy, a small fraction of the gas has been converted into stars. It has just started this process of making stars out of gas. So what we see here is the gas shining. And the reason why the gas is shining is that some of these newborn massive stars have started sending light into the gas. And this is called ionization. So it takes away the electrons from the protons in the gas. And when the electrons fall back the gas shines. And the strength of this emission from the gas is simply related to how many massive stars have been formed. So by measuring the strength of the emission from the gas, you can measure at which rate is the galaxy forming new stars.
Although glowing with the light of millions of stars, each of the newly discovered galaxies is hundreds to thousands of times fainter than our Milky Way. Usually, smaller things in space tend to be less interesting for astronomers than larger ones. In this case, it is the opposite. Three of the new galaxies appear to be slightly disrupted. Instead of being shaped like rounded blobs, they appear stretched into tadpole-like shapes.
We can see that they are small and that they look disturbed. And what that means is that probably what we see is more than one galaxy actually colliding or merging, as it's called. So the picture we have is that the galaxies we see today, spiral galaxies and other beautiful galaxies as we know, they are formed by mergers of many small clumps like these things we see in the very distant universe. And the reason why they look disturbed is simply that we see this process directly, that small clumps are coming together.
With the discovery of the 9 tiny galaxy building blocks, we have come a small but important step closer to understanding our cosmic roots.